And 1, 7. And just so everyone kind of knows what our schedule is going to be, we're going to finish up 1, 7 this evening. And if we have time, we may start a little bit out of 1, 8. Then we've got next week. Remember, that's right before spring break. So we'll kind of review and then probably have our second exam right after spring break. So we're now going to go ahead and look at 1, 7. So we're not going to have an exam next week. It'll be right after spring break. 1, 7, we're now going to look at quadratic inequalities. Now these have a special step-by-step procedure to solve them. So the first thing we want to do is we want to set it to 0. Then we want to factor and solve. And these are going to be our critical points here. They're not solutions, they're critical points. And then we're going to plot them on our number line. And make regions. Then we'll check a number in each region. And then we're going to shade where they're true. So these do have an extra step here. We'll start off with an easier one. Now these should factor, so you shouldn't have to use the quadratic formula on any of these. They'll factor up nicely. And we're going to start with this one. We're going to start with x squared is greater than or equal to 81. So this is not linear anymore. This is quadratic. So we're going to move that 81 over. And then we have x squared minus 81 is greater than or equal to 0. And this is what we're going to be checking them in. So we'll go ahead and put a box around this. We'll check it in this one. It's easier normally to check it in the one where it's set to 0 than the others, than the original. Now, x squared minus 81, we can factor this as a difference of squares. So that's going to factor into x minus 9 and x plus 9. And we'll replace that inequality with an equal so we can solve it. And what would my two numbers then be? These are critical points. X minus 9 equals 0, so x equals 9. X plus 9 equals 0, so x equals a negative 9. So it's just like what we've done before. We just have to add on a couple of extra steps because this is an inequality. Okay, so we've set it to 0. We factored it. These are critical points now. And we put our critical points on a number line. And then we make regions. And you always have one more region than you have critical points. So we've got 3 regions because we've got 2 critical points. Now we're at this step. We're going to check a number in each region. and we're going to see if it's going to be true or false. So the first region is for numbers less than negative 90. So we need a number smaller than negative 9. So we're going to have to check negative 10. Next, we need a number between negative 9 and positive 9. Any number in there will work, so we're going to use 0 because it's easy to work with. For region 3, we need a number bigger than 9. So how about we use 10? What the critical points do is they change it from being true to false. So they're where it can switch back and forth. Only place where it can go from true to false or false to true is these two critical points. So we're going to check them. And again, you can check them back in the original. I like to check it back in the one where it's equal to 0, or the factored version. So let's check region 1. And we're going to check x equals a negative 10. And let's see if this is going to be true or if this is going to be false. So I'm going to plug in my negative 10. Now, when we square a negative 10, it becomes a positive 100. And 100 minus 81, that makes it a 19. And is 19 bigger than 0? Is that true or is that false? Well, 19 is bigger than 0, so that makes that region true. So we'll mark this with a true. The second region, we're going to check x equals 0. This is region 2. And when I plug in that 0, I've got 0 squared minus 81 greater than or equal to 0. Well, is negative 81, is that larger than 0? No, that's going to be false. So that middle region then is false. And we're now going to check 10, because 10 is in region 3. And if I plug in x equals 10, that's 10 squared minus 81 is greater than or equal to 0. So that's 100 minus 81, and so that makes it 19. And 19 is bigger than 0, so that makes that third region true. And we're going to do several of these just to make sure we know how they work. So now we want to shade where it's true. So where are my answers true? Well, they're going to be true in region 1 and region 3 over here. We're going to use a square bracket because it's greater than or equal to. And then how do we write our answer? Here's how we write our answer. Reading it from left to right, we've got negative infinity with the parentheses, comma, negative 9 with the square bracket. We use a U to put the pieces together, to unite the pieces. And then what's our other side going to be? 9 with the square bracket to 10 with parentheses. So that will be your answer on that. So we only shade the true regions. And these critical points are where it switches back and forth between being true and false. When you pick numbers in the regions, you want to pick easy numbers. And it doesn't matter what you pick. I could have picked a negative 1,000. That would just be harder to work with, and why do that? For the first region, instead of a negative 10, you could have chose negative 1,000. For region 2, you could have chose 8, because you want a number between negative 9 and 9. 8 would be in there. You could have chose 16 on region 3. It doesn't matter as long as they're in that region. Most of the time, but not always, they switch back and forth in the signs. So normally it will go true, false, true, but not always. You have to check them. Let's try one now that has 3 critical points. So again, we're going to try and solve and graph this one. This one has already been factored. So this one has already been factored for you. I chose this one because it's going to have more regions to check. So what are my critical points? Well, this one's already done, so we can look at it. X minus 3 equals 0, so x equals 3. X plus 2 equals 0, so x equals a negative 2. And x minus 4 equals 0, so x equals 4. We always have one more region than we have critical points, so we're going to have 4 regions to check. Make sure they're in the correct order. So we've got a negative 2, a positive 3, and a positive 4. And that makes now 4 regions. If a whole number is not in the region, you'll have to use a decimal. Try to make them as easy as possible to work through. We need a number smaller than negative 2. So how about negative 3? That'll work. We need a number in between negative 2 and 3. 0 will be in there. That's easy to work with. We need a number between 3 and 4. There's no whole number, so I'm going to use a 3.5. And then we need a number bigger than 4. So we'll use a 5. Okay, we're going to check each region back in the original. So we're going to check x equals negative 3. And we're going to check that in x minus 3, x plus 2, and x minus 4 is less than 0. So we're going to plug in a negative 3 for x here. And let's see if this is going to be true or false. This is region 1. So we're going to plug that value of x equals a negative 3 in. That's going to make that then a negative 6. Minus 3 plus 2 is a negative 1. Minus 3 minus 4 makes it a minus 7. 3 negatives, keep it negative, and 6 times 7 makes it that 42. So it's going to be a negative 42. And is negative 42, is that smaller than 0? Yep, so that would make that region then true. Repeat the process for all 3 regions, or sorry, all 4 regions in this case. So let's check x equals 0. And that is then 0 minus 3, 0 plus 2, 0 minus 4. So that's minus 3 times 2 times a negative 4. 2 negatives make it positive. And we've got 3 times 2, which is 6, times 4 more makes it 24. And is positive 24, is that smaller than 0? No. So that would make that second region then false. They're not really difficult, they're just time consuming. So check every region. We have to do that though. Now we're going to check region 3. So we're going to use that 3.5 because there's no whole number in there. So we have to use a decimal. So we have 3.5 minus 3, 3.5 plus 2, and 3.5 minus 4. So 3.5 minus 3, that's a 0.5. 3.5 plus 2, that should be a 5.5. And 3.5 minus 4, that makes it a minus 0.5. There's a single negative, so my answer is going to stay negative. And let's work it out. So 0.5 times 5.5 times a minus 0.5, multiplying them all together, I get a minus 1.375. And is that smaller than 0? Yes, it is. So that will make that region then true. So we'll go back up and we'll mark region 3 as true. Next, check the fourth region, which is x equals 5. So work this out again, and that's going to be 5 minus 3, 5 plus 2, 5 minus 4. 5 minus 3 is a 2. 5 plus 2 is a 7. 5 minus 4 is a 1. No negative, so it stays positive. 2 times 7 makes it a 14. And is 14 smaller than 0? No, 14 is not smaller than 0. So that makes that region then false. Now, what do we want? We've got to make sure we shade the correct regions. So where are we going to shade at? We're going to shade region 1, and we're going to shade region 3. And what do they have? Well, back up in the original. It's a strictly less than. Remember, strictly less than, strictly greater than. Those get parentheses. Remember those. And strictly greater than or equal to, less than or equal to, those get the brackets. So these are going to have parentheses. And this is negative infinity. So what does my answer look like now? Right over here, because these are kind of hard to work out because they take up so much room. But in interval notation, the true region would be negative infinity to negative 2 with parentheses there. We use a U for union. 3 with parentheses to 4, also with parentheses. So that would be your final finished answer. The most that you're ever going to have is 3 critical points. And again, most of the time they switch back and forth. True, false, true, or false, true, false, but not always. So you have to be very careful with those. Make sure you check all the regions. Let's try 2 more of these. This one's only going to have 1 critical point. So again, we're going to try and solve and graph this one out. This one's only going to have 1, and we're going to have to check both sides of it. So let's go ahead and move that 25 over. And that leaves you then with x squared plus 10x plus 25 is less than or equal to 0. Now, why is this one only going to have one critical point? Well, the reason why it's only going to have one critical point is when you factor it, you get a 25, and what two numbers? Multiply together to give you 25, add together to give you 10, 5 and 5. So that will factor into x plus 5 and an x plus 5. And that's probably going to be the easiest version to check your answer. You can check it about anywhere, but I think in this case, that one's going to be the easiest place to check answers. We only have one critical point because this is called a double root. So what do we have? We have x plus 5 equals 0. So x equals then a what? Negative 5. Place this on our number line, and that's going to make two regions. Because we have one critical point, so we're going to have two regions. And let's use, how about x equals negative 6, because it's below. And then how about above? Let's use 0. And again, you can use any numbers that you want. You just want to make sure that you pick one number that is less than a negative 5. So it falls in here. Negative 6 is your smallest number, close to that. And then we need a number larger than negative 5. You could have picked negative 4, but 0 is easy to work with. So we're going to use the 0. Now we only have to check one critical point here. So we're going to check x equals that negative 6 first. And then that is negative 6 plus 5. And negative 6 plus 5. We're going to check it back in that. Negative 6 plus 5 is a negative 1. Negative 6 plus 5 is a negative 1. And negative makes it a positive. So that's going to make that then a positive 1. And is positive 1, is that going to be smaller than 0? Is that true or is that false? Positive 1 smaller than 0? No. So that makes that region then false. What about the other one? What about 0? 0 plus 5. 0 plus 5. That makes it then 25. And is 25 less than 0? No, that side is also going to be now what? False. Okay, now here's where we got to be careful about our inequality. Everything is false except that negative 5, because why is our answer going to be negative 5? This is false and this is false, but look back up and see what you've got. X is less than or equal to 0, right? And if I plug that negative 5 in, what do I get? 0, and 0 can equal 0. So this side is false, this side is false. So that means the answer is negative 5. That's it. Now, what would have happened if I would have changed it a bit? Let's talk about the different outcomes. Okay, so the answer in this one's negative 5. What would have happened if I would have changed it? Just so we understand the inequalities and how they work. Okay, the interval notation, there's nothing on here. The only answer that would work is going to be this right here, because you've got square brackets on both of them. So the only number that would work is that -5. Okay, because this side is false, and this side is false.
You would like to put that in brackets?
Yeah, wouldn't have to use anything else. Nope, it's just going to be your x equals -5. Now let's change this a bit. We're not going to rework the problem. I'm just going to change the inequality symbol. And we're going to look and see what solutions we would have. So let's say I change it to this. Let's say it's strictly less than 0. Same regions again. And this again is false and false. Now, what would this one be for my solution? Well, the last one, it could equal that -5, right? What about this one? This one, it cannot equal -5, so this one's a little bit different, and you would have no solution. And why does this one have no solution? Because it cannot equal 0. See the difference now? Slightly different there. One has the number -5, okay? And one has a solution, one has no solution. Let's flip the inequality symbol around and see what we would get. Let's say now it's going to be greater than or equal to. Well, let's not use greater than or equal, just so it comes out right. Let's use a strictly greater than 0. So make sure that's what I want here. Yeah, because we want to include it. Okay, so greater, yeah, we'll use greater than or equal to 0. That way it'll give us what I want to see. Okay, if it's greater than or equal to 0, we would have the same -5, but when we go to check, we would check again -6 and 0, but what's going to happen now? If I check these now with our inequality symbol flipped, what's going to happen to the trues and the falses? If I plug in that -6, we already factored it, we know what it should be. If I plug in that -6, that's clearly in region 1. If I plug that in, I have -1, -1. That makes it a +1. Is +1 greater than 0 in this case? Yes, so that would make that region then true. This one's going to give us a completely different answer. What about x equals 0? If we check x equals 0, that's 0 plus 5, 0 plus 5, and that gives us then 25, and is 25 bigger than 0? Yes, that would make that then what? True. Now, what would the solution set for this one be? See, I switched the inequality, so it's going to switch the solution set. Okay, we shade the true regions. It covers everything. So what would the solution then be? Negative to positive infinity. You see the difference now. So this one's all true. So it's like an identity. Negative to positive infinity. The other one, look at the last one that we did. It was all false, so it was what? It was all false, so it had no solution. Let's look at one more of these, and then we'll look at rational inequalities. So we're going to try and solve and graph this one out. Get that squared there. And let's use a negative 4x. So this one's going to be very, very easy to factor. Now, this one is also going to give me 3 critical points. So let's go ahead and move that 4x over. And now we've got x cubed plus 5x squared plus 4x is greater than or equal to 0. Now, notice my highest power is a 3. So that tells you now, at most, you're going to have 3 critical points. That's the most that you can have. Highest power tells you how many you can have at most. You can have less than that, but you can never have more than that 3. So what can I do? Well, I can factor an x out, because they all have an x in common. And then first times the last is a 4. And 4 and 1 gives you that 5 in the middle. So that's going to factor into x times x plus 4. X plus 1 is greater than or equal to 0. So now how many critical points we have? And we're going to check our solutions in this one. It's going to be easiest to check right here. Only your last step of the inequality is where you'll check it. Now we're going to get 3 critical points. Why are we going to get 3 of them? Well, one of them is x equals 0, because it came from the x that we factored out. Then we've got x plus 4 equals 0. So x equals a negative 4. Then we've got x plus 1 equals 0. So that gave me the negative 1. So those are now going to be my 3 critical points then. We're going to place these on our number line. Make sure they're in the correct order. Very, very important. So negative 4 is the smallest. Then we've got negative 1, and then we've got 0. So we've got 3 critical points, so we're going to have 4 regions. So region 1 is for numbers less than a negative 4. So let's use a negative 5. Region 2, number between negative 4 and negative 3, or sorry, negative 1. Let's use a negative 3 because it's in there. Negative 1 and 0, there's no whole number. So we'll use a negative 0.5. So that's about the easiest one that we can use here. We need a number larger than 0. How about 1? Those are my 4 numbers I'm going to check. We've got 3 critical points, which means we have then 4 regions. Is everyone okay with that so far? Everyone see where I got those numbers? It's very, very important you know where I got the numbers from. Doesn't matter what number, as long as it's in each region. So we're now going to check them, and we're going to check them back in our original. So we're going to check them all in this. We're going to check them in x times x plus 4, x minus 1 is greater than or equal to 0. So we're going to plug them in. We're going to start with a negative 5. And this is region 1 here. We've got negative 5 times minus 5 plus 4 times minus 5 minus 1. That gives you a minus 5. We've got minus 5 plus 4. That's a minus 1. Minus 5 minus 1 makes it a minus 6. 3 negatives keeps it negative. So that's going to be a negative 30. And is negative 30 bigger than 0? No, negative 30 is not. So that means region 1 is false. We're going to repeat the process here. Negative 3. I plug in that negative 3. I've got negative 3 times negative 3 plus 4 times negative 3 minus 1. So we've got negative 3 minus 3 plus 4 makes it a 1. Minus 3 minus 1 makes it a minus 4. Two negatives makes it positive 12. Is 12 bigger than 0? Yes, it is. %90 of the time, they're going to switch back and forth between true and false. But don't just assume that it's going to do that, because there are some where it does not. It may go false, false, true, or true, true, false. You don't know. You have to check them. But majority of the time, they're going to switch back and forth. Let's check a negative 0.5 here. So plugging in that negative 0.5, we've got a minus 0.5 times a minus 0.5 plus 4, and a minus 0.5 minus 1. Okay, so it looks like we've got a minus 0.5. We've got a 3.5 in the middle, and we've got a minus 1.5 on the end. Two negatives make it again. Make sure I plugged everything in right here. Let's make sure I did it correctly. Yep, everything looks right here. Okay, we've got two negatives. That's going to make that then a positive. Okay, make sure I did the last one. Yep, everything looks right. Just make sure I didn't make a mistake anywhere. And we're going to see we've got two negatives. It's going to make that positive. And multiplying across, we now have 3.5 times 1.5. Okay, that's going to make that then a negative, or so negative makes it positive, positive 2.625. And that is now going to be greater than or equal to 0. So that would then be what? True again. So we don't always have to be the same. Okay, now we're going to check our last one, which is 1. So if I pick that 1, let's see what we have. We have 1 times 1 plus 4, 1 minus 1 there. And that's going to be now greater than or equal to 0. Let's see, did I copy something down wrong? I want to make sure I didn't make a mistake here, because something doesn't quite look right. Oh, yeah, it should have been a +1, shouldn't it? Yeah. I'll have to fix these. Sorry about that. I'll have to fix these. I was wondering why it didn't look quite right, so let me fix these real quick. Okay, so this one should still stay. Then my mistake here. This one will still stay false. If I use a +1 here, that one's just going to make that a -2. So it stays true. But this one, my mistake here, sorry about that. That will make that, I was wondering why the signs didn't switch back and forth. That will then make that a positive 0.5. Just let me fix that. At least I got it before we wrote it all down. That then will make it, when we multiply across, 1 negative keeps it negative. 0.5 times 3.5 times 0.5 again. That makes it a minus 0.875. And sorry about that mistake. Greater than or equal to 0. Well, again, that one would be false. Sorry about that. I knew I copied something down wrong. So make sure you see that middle is going to be false here. And the last one, make sure you switch that sign. If I plug in that 1 on the last one, If I plug in that 1, I have 1 times 5 times 2, and that makes it 10. And is 10 greater than or equal to 0? Yes, it is. So that one's going to be true. Okay, so that makes that region then true. And where do we shade? We're going to shade here in region 2. And we're going to shade over here in region 4. And it looks like these are going to get square brackets. And this goes to infinity. So what's my final answer going to look like now? In interval notation. Well, it looks like it's going to be -4, comma, -1. With the square bracket, we're going to use a U for union. Square bracket, 0 to positive infinity. And remember, infinity, no matter what, gets parentheses. Sorry about that mistake there. I knew I made some kind of mistake. I just had to find it. But that's going to be your final answer. Now let's talk quickly about rational inequalities. We'll just do one of these. We'll take a break. We'll come back. We'll do some more of them, and then we'll look at some applications. And that's probably going to finish up this evening. So let's do one of these, and I'm going to pick one from the textbook. This way it comes out to be nice numbers to work with. Find one here to work through. We do have a step-by-step procedure for these as well. Let's look at about 57. So page 178, question 57. That looks like a good one to start with here. Now, when we talk about rational inequalities, we have a step-by-step procedure that we use. So rational inequalities, these are the fractions. Step number 1 is find the numbers not in the domain, just like we did before. Number or numbers not in the domain. And they are always, no matter what, going to have parentheses. So we find it and it's not in the domain, it's always going to have parentheses. Step number 2 is we clear our fractions and solve. Step number 3 is we plot our points on the number line. Now for step 2, they can either have brackets or they can have parentheses, and that's going to depend upon the problem itself. So we're going to find the numbers or numbers that are not in the domain. That's going to be a critical point. Then you clear your fractions and you solve it. Now what comes out of there can either have a square bracket or it can have a parentheses. Then we plot them on the number line and we check each region and shade the true regions. It sounds more complicated than what it actually is. It's very simple. We just find the number not in the domain, clear our fraction and solve it like what we've been doing before. Now, if it comes from the number that is not in the domain, that is always, no matter what, going to have parentheses. Whatever we clear and find can either have square brackets or it can have parentheses. Put them on a number line and we check our regions. So we're going to look now at question 57. And this is x minus 3 over x plus 5 is less than or equal to 0. So let's try to follow our step-by-step set of directions here. So what's the first thing we need to do? Well, the very first thing we need to do is find the number or numbers not in the domain. Okay, what is not in the domain? Well, x plus 5 equals 0. Can I copy it down right now? So that's going to give you negative 5. It's going to have parentheses. Is everyone okay with that so far? So just like what we did when we solved them when they were equals, right? What did we do? Step number 1 was always find the number that was not in the domain. Okay, so we did that. Now, once we have that negative 5, and by the way, always try to box your original inequality because that's what we're going to have to check it in. So when we check these, we're going to check them in our original. And this is question out of your textbook, 57. Now, what do we do for the next step? Clear our fractions. So x minus 3 over x plus 5 equals 0. I'm going to write that as a 0 over 1 so I can cross multiply. It's going to be the easiest way to clear out these fractions is to simply just cross multiply. So cross multiplying, that gives you x minus 3. Because 1 times anything is just itself. And then on the right-hand side, x plus 5 times 0 is still what? 0. Add your 3, and we've got our second critical point. Now, the first one was negative 5, and it got parentheses. What about the 3? Well, the 3 is going to get square brackets. Why? Because of that. So when we plot these and graph them, one of them has parentheses and one of them has a square bracket. And we'll take a break after this question. So we'll put these on our number line here. We've got negative 5 and we've got a positive 3. Let's break them out. Region 1, region 2, region 3. And we're going to use negative 6. We're going to use 0 because it's in there. And we're going to use a 4. We check it back in our original. So we check these in. X minus 3 over x plus 5 is less than or equal to 0. That's what we're going to check them in. And we'll start with the negative 6. So that's minus 6 minus 3 over minus 6 plus 5. Minus 6 minus 3 is a minus 9. Minus 6 plus 5 is a minus 1. Negative and negative makes it a positive 9. And is positive 9, is that smaller than 0? No, that would make that then false, wouldn't it? So that region is then false. What about in between them? Well, in between them, in the middle, we wanted 0. So we're going to plug in 0. So that's 0 minus 3 over 0 plus 5. That makes it a minus 3/5. And is minus 3/5. Is that smaller than 0? Yes, it is. So that makes that region then what? True. We've got one more to check. We're going to check x equals 4. So that's 4 minus 3 over 4 plus 5. And that needs to be less than or equal to 0. So 4 minus 3 is a 1. 1 plus 5 is a 9. And is 1/9. Is that smaller than 1? That is now false as well. Where do we shade? We shade in the middle. Make sure, though, that you use the correct symbols. 3, we talked about, it's going to have a square bracket. And if we go back up and look, -5 came from the denominator, so it gets a parenthesis. So there's my number line. We've got it all diagrammed out. So what's my answer going to be? Well, my answer will be, and I'll just write it over here, my answer will be parentheses -5, comma 3 with a square bracket. So let's go ahead now and take a short break. And let's meet back here at, let's say, how about 8:55? So meet back here at 8:55. We'll come back. We'll do a couple more of these, and then we'll look at some applications.